Uh, I will do a little bit presentation today on the production of green hydrogen. I'll run you through a little bit about the company, who we are, where we're from, and what we're doing, and the way we see the business and the market. The main topic today will be smart, just-in-time production of hydrogen. We need hydrogen to fuel all the applications we do with all our partners, and this is important that we have the hydrogen available whenever we need it in the right quantities at the right price. Green Hydrogen is a Danish company. We established 2007. So we've been in the market doing pressurized alkaline systems from the start. That was the foundation of the company. We have focused on being scalable, modular units in order to have a quick return on investment when you buy our equipment, to have the pricing down so you can have actually some business cases and not just some cost. A little bit closer. Okay, that's better, yeah. There's not so many. I thought someone was sleeping, so. No, since 2007, we've been doing the alkaline systems in Denmark, and we focus on that. We focus on getting the cost down, the efficiency up, so it will be a generator to actually generate green hydrogen, can support different business cases. And we are doing this all with our partners because we all know that very few just buy hydrogen. You actually buy hydrogen because you have an application that you need to do, so that's why we do it with partners. So we go to the market with our partners, so it means also that we can be locally represented around in the world without having our physical presence. So we want to really work with the partners, and that's a clear strategy from day one. Basically, we got two different solutions. We got an alkaline solution and we got a small PEM. So the small PEM, if we take this on the one side, it's a 1 normal cubic meter. It's a small compact system that can be used for small applications, and we often see it for small off-grid, for universities, some small industrial applications. But this is actually to know the PEM technology, so we like to have it in-house, so we know it. The one that we have our focus on is more the alkaline system. The alkaline system is in bigger modules. It's more utility grade. It's 30 to 90 normal cubic meter in each module. So it means it's basically from 65 kilos a day in one module up to 200 kilos a day in the production capacity. What we have done is normally the alkaline, you say, it cannot really be dynamic. You cannot go up and down. You take a good old electrolyzer alkaline, you turn it on, you leave it for 30 years, and you turn it off again. But we wanted to change that, so that's why we made it pressurized, so it's very compact, and at the same time we are able to follow the different energy sources that we have. That's also the name of the company, is Green Hydrogen. So from the beginning we've been working on fluctuating energy, and that is now in the product. This is what we can do. On the modules we go from 25 to 100% in less than a split second, and when we do clusters we can go basically from 1% or 0% to 100 in less than a second. So basically we can do the same that you can do on a PEM system and what you expect from a new modern system today. What is important is also that basically the modules that we do, they have a dryer and deoxer directly integrated in the skid frame, so everything is integrated, so each module is a complete system. So that means it's very easy to make the redundancy. You add one. You can do an N+1, or you can do more. You can do load sharing however you want to operate it. So it's very easy, and you do not have, let's say, a single point of failure. It's very easy to build redundancy in it. The important thing when we come to the alkaline system is also the lifetime of the stack. We know from our PEM system we have 25,000 hours a lifetime on the PEM stack. But when we go to the alkaline, we have a 10 years lifetime with an expected degradation of 1% per year. So even after 10 years, we will expect to be around 90% efficiency, which is relatively high still after 10 years. And then you can renew the stack, or we can just let it run depending on the future electricity pricing. We see after 10 years, we don't have to decide until then. So it's also a possibility if electricity is cheaper in the future, we just run it at lower efficiency and the machine will still generate hydrogen, and you'll have an even better business case. In order to operate it and have low OPEX, it's important that the system is automatic, so you don't have any human intervention. That you just basically you can operate the system and run it from remote. You can do everything that you want remotely and manage it, see alarms, do studies, so you can take all the data out, how much has been produced, all kind of data can be retrieved remotely, and then you can put it in a system, and we can also do the remote assistance when there's a problem, or our partner uses it to access as well to do their, let's say, on-site assistance. So they can prepare on-site assistance by checking the system first, so they make sure that whenever they arrive on site to do some service and maintenance, they will have the right spare parts and everything with them, sending the right people. So again, it's more cost effective. You don't send the wrong people to a destination with the wrong tools. You make sure that we optimize everything in the chain in order to have as low OPEX as possible. The system can, like shown here, this is a, let's say, integration where we put more units together to have a higher output. I think this is about 10 megawatts, so we can do small and big, but we can also just grow as you want. We can start at the right size, and then we increase the capacity. We put one more module, either in a factory floor installation, or we put it a container, take a complete container, and if you need more, we can put another container, or we can make a factory floor installation. It's very easy. It's just a machine that produces hydrogen. It doesn't need that much engineering, because the engineering is inside, let's say, the skid frame. When we take a look at the market, also this is a study from Hydrogen Council, saying that right now we have the time frame here in the bottom, the expected market. This is showing where the start of commercialization and where you have the mass market acceptance in the market. This is not our model, it's a Hydrogen Council that made it. We have just at the top put in our products, our current products that we have, and the future development that we're building at. So we have today a product that fits to the market, and we will be developing bigger modules in the future, so we will be able to address new market areas as they emerge and as they become real. We really, of course, there exist today many test sites projects, but we're really looking more at what will be commercially, because we look more at the business case and not just at doing a test. We want it to be really commercial, so that's why we focus very much on what the expectations are to the market when the market will be commercially available, so we actually can sell on normal commercial conditions, because that's our objectives. Here's an overview of the partners that we work with in the different places in Europe, like Proton Motor Fuel Cells or Oaser in the north part of Sweden, Nielsen Energy. We got working with Engie in other parts of the world, Tractobel, GFV, Windenergie. We work with a number of partners, and that's very important for us that we work with partners, because together with the partners can actually create a complete hydrogen chain. So you can have the complete solution from renewable energy production to the hydrogen production to the consumption in an application. It could be a maritime, it could be a boat, it could be whatever, it could be a bus, industrial, power to gas, whatever, but we want to do it with partners. So the partners are the ones that will be locally represented and be facing the direct end user. So if we look at the hydrogen production, which is the way that we see it, we want to try to make it maybe a little bit more intelligent. We want to be just in time. We just want to produce the hydrogen when it's needed. We want to avoid unnecessary storage of hydrogen in order to keep the storage cost down. So by knowing the consumption, it's easier to predict how much hydrogen you need to produce, so we can produce more just in time and less to make a big storage and then hope that we will use it someday. This, of course, it's a benefit for us, because if you want to produce just in time, you need a higher production capacity to produce just in time. So, of course, for us, it's interesting to have more electrolyzers, but at the same time, you can also build more redundancy into the system. But if you know that in 2 hours you need so much hydrogen, you can start the machine, you produce. So we do not store from the last week, but we produce just in time for special applications. It's also very important that you do it, let's say, integrated with the complete chain. So you need to get information back from all the applications that's running. So that's why we need to work very closely with our partners in creating this. So the partners that are making the applications are creating the demand for hydrogen, and then we just work together with them to fulfill it at the best possible way. For us, business case starts with money. So when we talk money, we have to look at what is the price for the green hydrogen that we produce. So our modules has been done in a smart way, so we can actually produce them at a good price already today. And this is not the projected prices for 2020 or something. These are actually the pricing that we can deliver today. So based on a system in a container, so a complete system, you just need to add electricity and water, and you'll get the clean green hydrogen out of it. 10 years operation, 6,000 hours per year, including service, maintenance, including electricity at 40 euros per megawatt hour. You have a production price of, let's say, basically 3.5 or less euros per kilo for green hydrogen delivered on site over the next 10 years. And we really believe that by being able to support and deliver solutions like this, the green hydrogen is easily available for different applications where you need them without any need of transportation or anything. And that's a very important factor to be a business enabler, to help companies make the transition to use hydrogen in their business for transportation, for industry, energy storage or whatever. It's important that it all starts with a good price of the hydrogen. We have also looked a little bit, of course, why do we want to focus on doing it just in time, and why do we want to focus on doing it on site? When we look at the standard price for producing hydrogen centrally, green hydrogen, you have a production price of around 4.4 euros per kilo at the central site. That's the official figures you find in the market for large scale 10 megawatt, 100 megawatts sites. Then you need to transport it, which has a typical price of around 1.4 euros per kilo. Now, of course, it all depends where you transport it, the distance, the conditions. But these are the well-known figures in the market. And you end up at a price at a customer which is about 5.8 euros per kilo. And at the end of the day, the hydrogen is not green anymore because you do the transport in a normal truck. And nowadays there's very few hydrogen-fueled trucks to transport the hydrogen. So you end up having a price which is 5.8 euros at kilo at the site, where compared to the local production, when you let the energy flow and transport the energy in the wind or in the sun to the site where you then produce the hydrogen, you end up at a price of like 3.5 euros per kilo. So there's a big difference, and you make sure that it's actually green. So you can also make sure that you consume green hydrogen at the site, and you can get the green certificate that you need. Everything is in a circular economy. It's a good part of this to be in a local ecosystem where you actually produce and consume the hydrogen locally, and at the same time it's much cheaper than centrally produced, which is a win-win situation. So what we want to do is help democratize the future power production. We looked at what has been done with the wind industry, what has been done with the solar. Today everybody can have solar on their own roof. Wind energy is spread all over the globe, and we can do the same with the hydrogen. Why should we go and concentrate and centralize everything like we did with the fossil? The fossil, we had to do it because we had the oil coming from Saudi or somewhere, and we had to put it to a refinery, and then we had to transport it to the final destination. Here it's much easier using the new modern technology. We can let the sun and the wind transport the energy or the water, and then we take it and produce it, convert it locally to hydrogen and use it locally. So we avoid a lot of the cost, and we also avoid centralization. And at the same time, when we decentralize, we can be the enabler of local ecosystems running on hydrogen. So the local ecosystems can have applications. You can create work jobs locally, working using the hydrogen. It can be service, it could be installation, it can be a system integration where they take a fuel cell and put in a truck or in a boat locally and do this. So it really gives a lot of local economy advantage that you can keep the money in the local society and not send them to the big companies. There will be we can really democratize and put it out to everybody that can do this, and that's really what we can do with the technology if we do it smart. What we also focus a lot on is working with our partners. We want to distribute the knowledge that we have on hydrogen to our partners, and the partners will then distribute to the end users. So we want to create more knowledge in the society about this technology, because the more knowledge, the more new jobs will be created, and it all helps the complete ecosystem. So green hydrogen, we see more ourselves as a business enabler. We are, of course, we have some products that we deliver. That's for sure. That's the machine. But the most important thing for us is what you can do with what we deliver, and that's why we really want to help our partners. We want to help the society in a different way. We have a big focus on making solid business cases and not waiting for subsidies, but trying to focus on models where we can actually do business without subsidies, because it makes business sense, like any other business. There's so many businesses that do not rely on subsidies, and we really believe that with the price of hydrogen that we can reach, we can actually do a lot of things already. And actually we are, just a few reference that we are doing something locally. For instance, here in Sweden, we do now with the solar panels off grid, we do the green hydrogen on site, which is stored and then put into the refueling station that was already existing. But the refueling stations used to get the hydrogen delivered from 300 kilometers away on a diesel truck. Where now they can just produce it locally and store it locally, and at the same time they will use the hydrogen for other purposes, because suddenly you have hydrogen available in the local community at a price, and suddenly it makes sense, let's say, to do take a hydrogen genset to make back to electricity for a music festival or other things. You have so many new applications. You have the local ferry that goes and say, okay, why don't you take and make the ferry run on hydrogen, and then you can use the hydrogen that you produce locally. You suddenly have so many things that you can do now that you have hydrogen available locally at a good price. So this is one of the examples of producing and consume locally, which is important. So there's no transportation. Once it's installed, that's it. Another application that we're doing that will be up and running this summer is a housing estate in Sweden, also where you got 172 apartments that will be off-grid. So you say, yeah, but they were on grid, yes, but now they will be off-grid. So the company owning all the buildings, they renovate, they do isolation, they make them up to date, put solar panels on the roof, make a solar panel park, store the energy from summer, and then use it in the winter using fuel cells to make electricity and heat. And this is a real-life example as well, that it really works. And what's interesting is that making the renovation, of course, they cleared out all the apartments, but after that, they put them on the market again. They put them at a higher price, and there were so many people that really wanted to live here, and even though that it was much higher price than similar apartments, people are willing to pay a premium. So actually it's a market demand, and it's not a subsidized project. It just shows that there is a requirement from the market that they really want to do this. And again, we are just also a business enabler, helping to produce and consume locally in an application like this, and we hope to see many more of this. And this is also done with our partners, so we show that the model works, that the partners has the local presence, has the local footprint, and we work together with them to make it come true. The last one is in the transport sector, so it's the one we will make the first bus refueling station in Denmark. So we do that also together with another partner, which is also present at our booth. So again, we produce and consume locally. The hydrogen will be made locally, will be consumed locally by the local bus company. So it's in this way we really want to work. We really want to push forward on producing and consuming locally, and being a business enabler to help you also make some profitable business, find the business cases at the clients that are valid and that we can work for.
Thank you very much, Henrik, Steen, Pedersen. Are there any questions from the audience?
could you perhaps say a few words to the maritime application and how you see your technology being integrated for vessels and so on, in ports, for example?
Yes. So for us, maritime is also in the transport section. So we already have several projects that we work on that to make the hydrogen in the harbor. Because in the harbor, it's very interesting. You typically you have a lot of big consumers. Today, of course, they consume oil in one way or another. But we got one project in the southern France where we're working on, where the ship will be transformed to run on fuel cells. And this fuel cell boat will be able to transport the passengers, which will more tourists, which will be completely quiet and silent when they go out on the sea, which gives a new possibility. But the thing for us is to produce again and the electricity, take the electricity locally, produce the hydrogen locally. So you'll have a refueling station at the harbor. On one side you can refuel the boats, and on the other side you can refill buses, taxis, and other applications. So it's just, again, it gives an enabler to make a system around you. And this we, of course, we address with our partners to do in the maritime. And let's say we got some projects also in Norway. And basically each fjord in Norway will, at the end of the day, will have their own refueling station. And again, here we have, typically we have hydropower. There's a lot of water power, hydropower in Norway. So the hydropower will then be used to make the hydrogen locally in each fjord. So this is the ambitions that we see, and this will then enable also the market for the maritime sector, because suddenly you have the fuel available, and now it's much easier when you order a new boat. You can take the fuel cell version or the battery version, or you can take a hybrid, or you can with a range extender. You can. Or you could take a classic one, but the classic ones running on oil will be banned at some point in the near future.
Thank you very much. Looking at the time, we have to continue, but if you want to discuss the topics any further, please go to the booth D69 and he will be around to take all your questions. Thank you again.
Thank you.